Okay, now we don't have our key that says which one is A1 and B1 or C2 or the other numbers, because we want to now try to do it without that key and check if we remember which number goes where. So we won't be writing on the side the value of each variable. We are going to try by doing it just watching the equation. So first we are going to solve for the determinant of the system. We write our bar. Now I already identified that the first column, so the first term should be x, and those are going to be our a's. The second column, which should be our y's, is going to be our b. And the number after the equal sign is our constant number, which is the c. And the number, the subindex, represents the number of the equation, which is 1 or 2. Okay, so knowing that, let's now fill our formulas. So a1 should be 1. The coefficient of x, remember, if it's not written, it means that's just 1x, so it's 1. And then the x of our second equation, also 1. Now it says b1, b2, which is the values of y, the coefficients of y. The coefficient of y of the first equation is 1. The coefficient of y of the second equation is 2. Okay. Now I solve the determinant by multiplying the first diagonal. Remember, our first diagonal is going to be in that direction, upper left to bottom right. So in this case, 1 times 2, 2, minus our second diagonal, which is going to be from lower left to upper right. Okay, so minus, in this case, is 1 times 1, 1. 2 minus 1, 1. That is the determinant of the system. Now let's find our value of x. We write the bar of our determinant, and the first column is the values of c, the values of c of our first and second equation, which are the constant numbers. So 5 and 3. Now our second columns are the values of b, the values of y of our first and second equation. In this case is 1 and 2. And we are going to divide that over the determinant of the system that we already found is number 1. Okay, now we cross multiply again with our main diagonal, upper left to bottom right. 5 times 2. 5 times 2 gives us 10 minus our secondary diagonal, lower left to upper right. 3 times 1. 3 times 1 is 3. And we are going to divide that over 1 equals 10 minus 3, 7 over 1. And 7 over 1 is 7. So now we know that x equals 7. Now let's find the value of y. We write the column, the bar of our determinant. The equation says that the first column is our values of a of the first and second equation. So 1 and 1. We have 1x on both equations. The second column, the values of c of both equations. So c are the last numbers, the constant numbers. The first equation has a 5 and the second equation has a 3. And we will divide that over the determinant of the system that we already calculated, that is 1. Main diagonal, 1 times 3, 3, minus secondary diagonal, 1 times 5, 5, over 1. 3 minus 5, minus 2, over 1. And minus 2 over 1 is minus 2. So we found that y equals minus 2. Okay, but now we have to check our answer. Let's check here. Check. Let's start with our first equation. Our first equation says that x, which is 7, plus y, which is minus 2, should be equal to 5. plus minus, positive times negative becomes negative. So 7 minus 2 equals 5. And 7 minus 2 is 5. 5 equals 5. Yes, we are correct. Now to check with our second equation, it says that x, 7, plus 2 times the value of y, which is minus 2, should be equal to 3. 7, positive 2 times negative 2, positive times negative, negative. 2 times 2, 4, equals 3. And 7 minus 4 is 3, which is equal to 3. We are correct. Okay, so our solution by determinants is pretty straightforward. We only have to identify where each number goes and follow the formula. Okay, so this was solving a systems of equations of 2 by 2 by determinants. Thank you for watching this video.